Oh, mic is on. It must be time. Well, hello. Good, kind of still good morning, almost not quite morning anymore, this late morning session. And last day, are your heads filled? And I hope you're still ready for a little more. My name's Julie Lerman. Some people may know me for Microsoft's ORM called Entity Framework. But this is not an Entity Framework talk, although you might see some Entity Framework in there. I might even say it. But what I'm going to be talking about today is using Docker with actually having containerized databases to make development and testing and even your CI/CD process and for the time in our lives when we're ready to like go for it with Docker in databases in containers in production, right? This is still a path along the way for it. But really this is about being able to be agile as you're doing agile development with your code, being able to be just as agile about your database and changes and migrations and schema changes to your database throughout your development process. So, I'll stop doing this. It's comfortable back here because I'm not blinded by the lights, but I know from watching somebody else that that puts me in the shadow. So I will walk into the light. Hopefully it's not that light. So now I can't see you anymore. Sorry. So who here has some good experience with Docker? Awesome. And who here has some good experience using source control with your teams like GitHub or something else? All right. Okay. Who here is like, DevOps kind of person? All right. So I am not a DevOps person, and I actually learned about pipelines in order to do this talk. Um, so I was pretty impressed with myself. What can I say? It's fun to have excuses to learn new things. So most of us here are developers, though, and hopefully you get involved with the software design process. Maybe you saw me talk about domain-driven design or some of the other DDD talks too, which I care a lot about the software design process. And your software, your ideas about what's needed in the software and your understanding of business processes evolves over time while you're working on your software projects. And not just on software, like all kinds of design. I'm really happy to, let's see, which side is it on? Yeah, that one. I'm really happy to have like this really nice titanium bike that I can ride instead of that wooden one that doesn't even have pedals. So I'm happy for that kind of evolution of design ideas. Hopefully your software design doesn't take as many centuries as that did, though, however. But they're still tweaking bike designs as well. I actually, my first new bike in 25 years, has electronic shifters. Oh my God, they're amazing. Anyway, so I'm a fan of things evolving and ideas evolving and letting your bike or your software be agile enough to evolve as your ideas about how the business is working. And while we're doing that, it's we have all kinds of tools to help us. We can do unit testing while we're building our software, right? Most often, we need to persist our data from the software that people are using. Who here builds anything that does not persist data? I mean, that is possible, right? So we eventually have to persist data. But we can go a long way with our software building without having to worry about database persistence, right? And even with testing. So unit tests, obviously, they're not even going to touch a database. But still, we want to make sure things are processing in the correct flow. And we have integration tests, and we can even mock the database, right? We can use mock tests to pretend the database is there without still having to worry about the database. And while we're in this process, it's pretty easy to share our source code and our tests across the team, right? Across different developers on our team who are working on their own machines, or people who are doing testing, people who are doing UX. And we can even push that right into our CI/CD pipeline, right? Because it's really just a matter of having a repository of your source control, and we can even include and take advantage of things like package managers so that each person's machine can go and get whatever it is they need. As you know, they're just compiling the application, it'll go ahead and pull the things that it needs. And we can use Docker containers also to provide components that we need. Who here is using anything like using other things in a Docker, like taking advantage of ASP.NET Core images or things like that? Not necessarily ASP.NET Core, right? So we can actually create images that leverage the existing ASP.NET Core images and then put our own applications, our own running DLLs inside of those images and to deploy them as containers, right? And the descriptions of those images become part of our source control. So you hand it off, somebody put it up in your repository, another developer or tester grabs it, and because of the Docker instructions, right, it'll go, if they don't have that image on their machine, Docker will make sure that that gets on their machine. So they don't have to worry about installing those things. So it's a pretty well-used process already over the years. Eventually, we're going to need to persist our data. We're going to need to test our applications and how they're literally physically interacting with a database, making sure that the data is getting in and out of there the way that you expected it to, right? A little beyond even what you can do with mocking or even in-memory testing database. And in addition to just making sure the data is getting in and out of there, you might want to do load testing, right? Like actually have gobs and gobs of data. And at the same time, we are starting to really think about, all right, it's time to persist the data. It's time to everybody needs to have the database server on their machine and the database is going to evolve as your models evolve, as your business evolves and you change your code and you change your classes. Your database also needs to evolve. So what I think a lot of people are doing now, so if you're using relational database, like some kind of SQL database, we'll have a SQL script, right, that we share somehow, maybe stick it in the repository. Developer gets it, and then they're like, okay, I'm just going to open up SQL Server Management Studio, and I'm going to run that C-SQL. Everybody's doing that. Or maybe some people are using SQL Command, or maybe some people are using Entity Framework migrations, right? And opening up the command line or PowerShell and just typing in update database, and it reads the migration file and applies that. But it's not seamlessly a part of your application like all the other source code in your application, all the other packages or even images that are being delivered by NPM or NuGet or Docker, right? And the database is always this other. And especially if you're using something like SQL Server, it's like a big weight in your computer, right? It's like, oh, we got a new version of SQL Server. I got to install it, right? It's just this big, immobile, unchangeable thing. However, now we have databases in containers, in Docker. Now, if you're using something like a document database, a NoSQL database, Cosmos DB or Mongo or something like that, you're probably not going to feel the pain of this as much because they don't have schema. You don't have to worry about the schema. And so as your models evolve, you just get newly shaped documents that go into in and out of your database. It's not really a big deal. But I think this is as of April. This gets updated every month by DB Engines. That red is, from their research, the percentage of relational databases that are in production, right? So people really still have to worry about this. Like, yeah, it's really easy if you just go to NoSQL, but still there's like, 75% or whatever that number is of people using relational databases. And of those relational databases, Oracle, MySQL, and SQL Server are the top used ones. So MySQL is a little lighter weight at least. And Oracle, I've actually never used Oracle. I've worked with clients who use Oracle, but I've actually never used it myself. So, SQL Server is the one that I really focus on. So I'm going to be, the ideas I'm talking about here apply to any other databases that are provided through images, through like Docker images, but I'm going to focus on SQL Server because that's totally my wheelhouse. So with SQL updates, whether it's MySQL or Oracle or whatever relational database you're using, and you're providing SQL, as I said, like it seems like everybody on the team kind of has their own way of dealing with the database, whether it's updating the database schema or getting the server onto their computer, et cetera. But why can't we have a process that's just as consistent and automated as how we're sharing all the rest of our source code with across our team and even into the CI/CD pipeline? So, ta-da! You may or may not know this yet, but SQL Server now has a Linux version. It's the same exact SQL Server as SQL Server that we all have, well, whoever has been using for the last, I don't know, decades and decades, but it runs on Linux. And once they were able to do that, then Microsoft was able to put SQL Server in a Docker image. And we can now deliver and use SQL Server images and containers just as fluidly as any other components that we're using in our system. Granted, the image is a little bigger than than like a little NPM package. There's no question about that. But there's a public Docker image. And if you're not using it in production, you can just grab it and use it, freely, right? In your development and test, just like we can, the SQL Server development edition. So I gotta see you again. Oh, I'm gonna do it this way. Who here actually uses SQL Server in their systems? Okay. All right, great. That's good to know. Who is there anybody did not know about this? I'm just curious. Did not know that SQL Server's in Docker? Oh, good. I let somebody know. That's pretty cool. So there's a few things to know about that, and I'm going to give you just a quick look also at what this means to have SQL Server in a Docker image. As a matter of fact, my first time I really kind of got Docker, really went, oh, now I get it, was because of this. Because I was like, oh, Docker always seemed kind of confusing to me, and I didn't get it. And, I had that whole well, it's kind of like a virtual machine, right? But it really isn't, because virtual machine has operating system right in it. This sits on top of the Docker engine and doesn't involve, which sits on top of your operating system, which sits on top of your infrastructure. So it's very, very different. So the first time I really had my aha moment was playing with SQL Server, right? That was like, oh, here's something I understand, SQL Server, right? I use databases all the time. Let me play with that, right? And that was where I really first had my, oh, right? And so now I use Docker all the time. I'm even a Docker captain, right? So this was my hook into Docker, which was kind of cool. So a couple of other things. So the image is available publicly. There's just a link there, Microsoft.com link of more information about SQL Server for Linux, and also the Docker image. Microsoft is now publishing. They had all their images on Docker, but they're now starting to publish their images on their own repository, which was kind of interesting because when there was a problem with Docker a couple of months ago, all the Microsoft images were safe because they were on the MCR repository. So you can actually find a path to it through the Docker Hub, which is kind of where you find all the public images. But also Microsoft has its own repository, which is at mcr.microsoft.com. And I think The new versions, like for example, all the stuff that's tied to ASP.NET Core 3.0, that's only going to be coming through MCR now, not through Docker Hub. SQL Server, like regular SQL Server, is also available on Windows containers, and SQL Server Express and LocalDB are in Windows containers. But Linux containers are so much easier to work with, and I can use them on my MacBook, right? Or on a Linux box, right? You don't need Windows to run Windows containers. So I really like that. So having this capability now, having SQL Server in a Docker image and having it just be readily available along with the rest of your source control makes the database now just another component in your system, not this other big thing you have to deal with that's completely disconnected from your application. So for the sake of when we're doing development and testing, we now have access to this much more fluid process when it comes to having to deal with our database. So I'm just definitely a big fan of that. So a couple of things to be aware of with containers, especially when we got, whether or not there's databases in them, whatever we're putting in them, but it's especially interesting to me for databases. First of all, a container is totally isolated. So we got Docker Engine, and then you can have all kinds of containers running on top of the Docker Engine. Docker Engine is, a piece of software that's running on your computer, an app that's running on your computer. So each container is totally isolated from each other. You could have multiple instances of SQL Server running on your machine. You could have multiple versions of SQL Server running on your machine. So maybe you're testing, you're about to, you're planning ahead to move to SQL Server 2019. You could actually have both instances running on your machine at once. And because Docker is managing the memory and it's inside of a container, you also don't have to worry about the amount of resources you would normally be expending on your computer to host those. I've actually never tried to have multiple instances of SQL Server running on one computer. But now that when I do it with Docker, I have a whole bunch at once. Another really interesting thing is it's portable. Anywhere that you can run Docker, you can run SQL Server now. That's, I think, pretty cool. You can have consistency now. Not only can you deploy SQL Server, but you can deploy ready-made databases already pre-configured by your DBAs. You can have them available, so you can have this consistency across. And because you can start a container so easily, and you can shut it down really easily, it's really nice to be able to say, I'm going to, say you're in a testing environment and you have to run a whole bunch of SQL servers kind of in parallel. So you can run all these tests in parallel. That's taking up a lot of resources, and then you can shut them all down because it's really easy to just spin them up on the fly. You're not installing SQL Server each time. SQL Server is already installed on the image. All you're doing is saying, okay, image, go ahead and start running. So it's a huge, huge difference. So maybe what I'll do first is show you, just to give you a flavor of what SQL Server looks like inside of a Docker container. I already have Docker running on my computer. This little icon in the upper toolbar here is kind of demonstrating that. I'm just making sure my font's decent size. Okay, so Docker's already running, and I already have pulled the image. It's just like pulling packages. I've already pulled the SQL Server image onto my computer, so we don't have to sit here and wait for that to happen. Although if we were doing it in my hotel, it would be really fast because the internet speed's like 450 megabits per second. At my house, it's 20. It's 20 times faster in a hotel than it is at my house. So that would be fun to just see that in action. But I already have that running. So, I think I have, just so you can see what this looks like. Okay, so just want to make sure you see it kind of more easily on a slide first. So you could just simply say, I just want to have that image on my computer. And the command is docker pull. And you just say the location of the particular image that you want. And so MS SQL/server is basically what the image is, but there's different variations on it. So we have these tags. Anything after the colon is a tag. So 2017 latest is a tag that will give me a particular version of the image. So that would just be pulling the image down so the image exists and is being managed by the Docker image on my computer already. If I haven't done that, there's all other things that trigger Docker to want to use that image. If the image isn't already there and being managed, then the first thing it will do is stop and say, wait, first I got to go pull it. So once the image exists, then you can run it. And the really big difference between an image and container is like an image is like a class definition, and a container is the running instance. It's the object. So when you're running an image, a running container, you say take this image and run it, and then you have a running container that's based on the image. So to run the SQL Server image, there are two environment variables that are required. So one is accept EULA equals Y. If you said no, I don't accept the EULA, there's no point in even typing any of this because it won't run. And then the other is you have to provide a password for SA, so the SA password environment variable. And there's some minimum rules for what the password should be, and my really cryptic password actually fits those rules, so that's one I use and I remember. Then I'm defining the ports to expose it on, but there's two numbers there. The first number is the port on my actual physical computer to expose it on. So even though it's going to be running inside of a container, I can get to it through, because I've defined it here as 1600, I can get to it through localhost 1600. Inside the container, it's exposed on port 1433. That's what those two numbers mean. -D is just if I want to have kind of an interactive mode to come back. That's close to exactly what that is, but I'm saying it not quite right. But that's okay. It's essentially, if you're running this at the command line, it's the difference between if the command line comes back so you can keep working on it, or if the SQL Server container is just going to hold on to that space, and then if you want to run commands on it, you have to open up a different terminal. And then the final thing that you have to say, these are the required, there's other parameters, but another important required parameter is which image we're talking about. So my image happens to already be on my computer, this MCR, Microsoft.com, et cetera, image. So Docker will recognize that and just use that. It knows that it's already there. If I hadn't already pulled it, if it didn't exist, it would go ahead and pull it down. Another interesting thing about images, especially big ones like this, is they're in different sections because they're made up of different things. So if you were pulling an image down like this one, you would see it would be coming down in like 9 or 10 different sections, right? And when they update it, you don't need all 10 of those sections again. So if you were going to update, you were going to get a new version and you just did Docker pull of this again, and there's a newer version of SQL Server 2017 latest, it would kind of list all the 10, and it would go, I already have that, oh, got to get this one, got to get this one. So even though it's really, really big, if you're going to update it, it's not, it's not a nightmare to update it because it's only going to get the little pieces that it needs. So I, by the way, have all these applications running because I'm going to be using them all during these demos, which is kind of crazy. So I'm going to Docker. Oh, I thought I made that bigger. Docker, okay, Docker run, make sure this is the right one. Okay, so there's the accept EULA environment variable. There's my password, that's the one I can remember. I'm exposing it on ports externally on here on port 1600, internally 1433. I'm going to get my command line back. I'm giving it a name, like the name I want to call it. So I'm calling it SQL via CLI, and then I'm saying which image I want it to run. So it's not going to pull it. It already exists. It's just going to go ahead and run it. Okay, the container is created. That doesn't mean SQL Server is ready. Something else is happening. The container has an entry point. Come on, refresh container list. The container has an entry point, and it knows that once it starts running, it has to run all this T-SQL. It's already finished. It takes like 25 seconds, maybe tops. That's setting up the master file and all those kinds of things. So that's it. The SQL Server is running and ready for me to work with. I can connect to it. Remember, it's got that external port. So I connect to it through Azure Data Studio. If you haven't used this, this is something Microsoft created. Oh, gosh. What port did I expose it on? 1600. Got a lot of moving parts here. Okay, so there it is, right? I can just do whatever I want with it now. There it is. But it's running inside of a container, which, that's pretty cool. So I'm going to close Kitematic, one less application I have to worry about as I'm going through over here. So that's just a really, really quick look at how quickly you can get SQL Server running in a container. First of all, so for all of you who have ever installed, who's ever installed SQL Server before? All right, did anybody just go, holy beep? Anybody? No? Just a couple people. Okay, well, believe me, I do it every time, except I do it quietly because it's kind of rude to swear all the time like that, like a sailor. So that's just giving you an idea of SQL Server in Docker. Now to using that and benefiting from that through development and testing. So I have a small solution. Again, it's a lot of working parts, but I have a small solution here. It's really, really tiny. And it doesn't need to be big and complicated because the whole point is just to show deployments and Docker and what's going on with the database. So I have a little model called Agilista to keep track of my friends who are doing Agile testing, and it's hard for me to remember what their focus is, right? So I have I'm keeping track of that. So, and their focus is based on some categories. That's my model. I have a couple of API controllers. One is called values controller, and that's just exposing or returning some strings. That has nothing to do with the database. I like leaving, it's a default that .NET gives you when you .NET new a web API, and I like leaving it in there while I'm building and testing, because if I run my API and something doesn't work, I can at least go back to the values controller and just make sure it's there, right? Make sure it's up and running. So the problem isn't that the overall application isn't running, maybe something I have to dig further into, like the controller that cares about the database. So that's what that is. And then I have a controller for these Agilistas. It's really, really minimal. I've got a getter that returns each of these people with that related data. I also have some tests. I've got some unit tests that just test some basic functionality inside my classes. And then I have some integration tests, some against the controllers, the values controller, and then some against the real database. I'll just show you quickly what some of that looks like. So I'm using Visual Studio Code. I love Visual Studio Code. All right, so here's my API, okay, in this folder here. Here's my API. Here's my models. Here's the Agilista class, no big deal. Here's the category class, which is it's just a little bit of related data. Here's the values controller, returns, the get returns value, 2 strings. And here's the Agilistas controller, and all this does. So here I get to say Entity Framework. I am using Entity Framework as my ORM, just so I don't have to deal with, just writing database stuff. So I have an Entity Framework DB context set up so that I can do things like query the database. So in this controller method, I'm just querying and pull. Hey, that's not going to run if I do that. I'm just, getting the Agilistas and eager loading their focus along with it. So that's what that controller is doing. And then if I close this, I've got my tests in a separate project. And my integration tests, I've got a few integration tests that just make sure the API is running, right? Like I hit the value controller and make sure some JSON's coming back, right? Just some basic stuff to make sure things are functioning properly. But I do have a test here that hits that get method, that HTTP request of the Agilistas, and makes sure that the data comes back matches some of the data that I'm seeding into the database for my test. So that's just a basic test that lets me know, yes, the database got created and it got seeded. Like so that the basic things I want to make sure some basic functionality is happening with the database. So how am I creating and seeding a database? Well, I have two SQL files here, right? Like sharing SQL to do migrations. So the first SQL file literally creates this database, right? And then it also creates some user roles here, creates some users, grants some permissions, and then creates the two tables I need for persisting that Agilista data along with the category that's their focus. And then it also builds an index for some foreign key, primary key constraints. The second SQL file is just seeding some data in there. So that's just my test data. It's not for performance testing. It's just like, 5 rows of data, no big deal. But it's just to make sure that I can do these minimal tests to make sure that the database got created, got seeded, and that all of my procedures are working. What else do I want to say about this? Well, I can run the API. If I have the database container already up and running and I've already done the migrations, I could run the API on Metal and use that 1600 port to get into the container. And I can run the API, I can run the controllers, I can run the tests. I'm going to skip over that, and I'm going to move to the next level of Docker, which is called DockerCompose. And what I'll do is I'm going to build an image for my API, run that image as a container, build a container for the database, migrate the database, and then run the API against the database. I'll show you how that's working, but first I just want to show you that it is working. I'll explain. I want you to see it running, and then I'll explain what's happening. It's always the chicken and the egg problem. Okay, so this is just the API running. And I'm just going to refresh this page. I'm exposing it on port 81. And I should get that same data come back when it refreshes. I always hate this part. Like, is it going to work? Is it going to work? It always works when you're practicing it at home. Now, in this case, it may have been spinning up the database while, this is why I like to go back and look at this could just be a timing problem, a race condition problem. Okay, the values are there. So let's go back to Azure Data Studio. Nope. Actually, before I dig into it to see why it's not working, I'm going to try it one more time. I'll show you what the moving parts are. Oh, come on. Okay, I'll show you what the moving parts are, and then I'll get it running. Okay, so some of the moving parts with respect to Docker are, I have a Docker file that is instructions for building an image, right? Not running a container, but just building the image. For example, an image that says, this is going to be ASP.NET Core, so I'm going to need the ASP.NET Core image to start with. And then here's my application, so go ahead and build that and then stick it into the image. Okay. The other is DockerCompose, and the DockerCompose is something that orchestrates the fact that I have an image for my API, an image for my database, and an image and a container that is going to do my migrations for me. And I think that's the part that hit the race condition, because I didn't put a big enough timer in there. Because believe me, this was all working. Any I think what I'll do is shut down all the containers and run it again and cross my fingers. Like, what did I do? Not shut down. I'm just going to remove them. Remove all the containers. Stick my tongue out at it because it's supposed to work. So that happened really super quickly. Flyway is still running. It's still doing its job of doing the migration. Refresh. Flyway is still working. Flyway is finished, so it should be done. And I'm just going to, because I've got different entry points here, I'm just going to double check where I'm exposing this. DockerCompose 1620. Well, we could just try it again. Phew, okay, now I don't have to screw around with it. I think it was a race condition, that I didn't leave enough time to wait for the database to be ready before I told Flyway, because I've got a timer in there. It says like wait 8 seconds, but maybe in this case it just like 8 seconds weren't quite enough for the database container to be ready and SQL Server to be ready for me to go ahead and run the migration. So that's all that was, which was a race condition. So how is this all happening? I gave you the overview of those files, but here, for example, I notice I have a Docker file and a Docker file test, and I also have a DockerCompose and a DockerCompose test. So the Docker file and DockerCompose, those are for the API. Those will build the images and run the containers and make sure that my API container can find my database container, and it'll also make sure that my container that's doing the migrations can find and execute on the database container. And it controls the timing and the order of those things. So that's for running the API with a controller. The other pair is for running my tests. So the Docker file, that's for building the image of the API. That's for building the .NET Core API, right? You could be doing this with all kinds of different frameworks. But that's for building the .NET Core API. And at the end, I'm telling it an entry point. The entry point means when I take this image and I run the container, the thing you should do is call the .NET command and do it against the DLL that's been built into there. So that's how it knows what's going to happen when I actually run the image. But this is for how to build the image. So what the Compose does, it's a little more complicated, but it's actually 3 pieces of information. They're called services inside the Compose file, but it actually represents the 3 different containers that I'm composing. So the first container is going to be my API container. And what I'm telling it in here is this is going to be the name of the image. So it's going to give an on-the-fly name and then -API, right? That's it's going to do that based on the name of my project. So it's going to be like Agilistas -API. And I'm telling it, look in the file, what Docker file do you need to know for how to build this image? It's just plain old called Docker file. So it'll know to read that Docker file that I just showed you. I also am letting it know that I have an environment variable that's going to provide the connection string. Okay? I'll show you that in a minute. And here is just, again, what ports it's exposing the application on, and you saw me go to localhost :81, and it depends on migration, which means I can't run this. This isn't going to be ready until after the migration has been run. So what is migration doing? Migration is using as a base an image for an application. It's a migration application called Flyway. Has anybody ever used Flyway? I think Sam Newman mentioned it yesterday, and it's I'm using it just because it was something new and interesting to use. I've always been using for so many years entity framework migrations, entity framework core migrations. So I wanted to use something outside of that, because if I was using entity framework migrations in my application, it meant either I had to somehow, especially if you think about production or on every single person's development machine or in my CI/CD pipeline, I had to somewhere either go to the command line and say, oh, create the database from the migration files, right? Like, where am I going to do that? Or I'm going to ask like every single person on my team to do it. Or I need to incorporate the migration literally into the API application, and I don't want to do that, right? I like separation of concerns. I don't want my application to be responsible for creating the database. So I'm actually letting Entity Framework create the base migrations for me, but then I tweaked them. You saw some of the SQL files that I was using. So I let it create the SQL first, and then I took the SQL, modified it, and I'm feeding it to Flyway. So Flyway, what I'm doing is saying, go get Flyway's image, and then give it a name, right, the container name. It's going to use volumes, so that's how it kind of persists some data outside of Flyway. And it's going to copy into its volumes those SQL files that I showed you. Right, so that's going to be accessible to the container, and then the entry point essentially is saying, okay, go. I've got to wait a little bit, because I have to wait for the database to be ready before I can do anything to it, and then it will actually run Flyway. Right, that's the command for the application, Flyway, and it knows to go and read the SQL files, and the SQL files are named in a way that Flyway has rules so that it will understand what order to run them in. So that's what I'm doing in the DockerCompose. I'm telling it to build, this other container. It's based on Flyway. Here's the SQL I want you to run, and here's the database. I'm giving the database connection string down here. Here's how to find the database, and then go ahead and run Flyway. All right, and when it's done, when it's complete, the container will shut down. That's not a command I'm giving it. That's how Docker works. Right? My API, when I run my API in the container, it just stays there and stays there and stays there, because it's waiting for me to run commands against it. It's the same thing with the database, right? But when I'm running Flyway, it's just like, do this thing. Okay, you're done. And because it's done, it's going to shut down. So it depends also now on DB. DB is the name of this third service. The third service is the one where I'm saying, use the SQL Server image, run it. Here are the environment variables I need to pass in when you do Docker run, and here's where I want you to expose it. So it's basically building up that same command line that you saw me type or go to, Docker run, right, blah, 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 to get that container running. So that's what that will do. But there's dependencies and timing in here. I also have an additional file within here does have another, like that 8-second definition that I've put in there. So this, again, a lot of moving parts. Another really interesting thing is you saw me connect to this database from my Azure Data Studio on my machine, because I was exposing it on my computer's localhost port 1620, right? So when my application is running, the API, it's inside of a container. And if it said, okay, the database is on your localhost 1620, it's going to look inside the container for localhost 1620 with SQL Server in it, right? And there is no localhost SQL 1620 inside the API container. Right? This is a mistake I made the first time I was exploring doing all this orchestration, because I was using local DB, like SQL Server local DB, right? That just kind of spins up. And, it's great and everything. And as soon as I started doing orchestration, it was like, I don't have that database. I'm like, but what do you mean? I had it before. I can browse to it. I can interact with it from Azure Data Studio. And then finally, I understood that it was looking for it inside the API's container. It doesn't exist. So one of the nice things that the orchestration does for you, that DockerCompose does, is because these are all orchestrated and they're aware of each other, this name right here that I gave to the service, I could have called it foo, but the service that is the container for SQL Server, that becomes the server name. So in my connection string, that is the server name that I'm using for the database. Okay, so that's how that orchestration is all working. And when it's running, I'll get back to migrations. When it's running, because of the DockerCompose, first it's going to spin up the database container, because I said, API depends on migration, migration depends on DB. So DB is the first thing it has to spin up. So now the SQL Server database is ready and waiting, but it doesn't have my database in there. Then it runs, spins up the container for the Flyway database, which runs the SQL script and applies the schema. Flyway finishes its job and goes away, right? So that container is no longer running. The image is sitting there, but the container is no longer running. Oh, I pushed the up arrow. I was like, no, the container's supposed to stay around. The database stays around. I pushed the up arrow. So that goes away. And then the third container starts running, and it's able to connect to that database, right? So we can interact with the API and be done. That just means somebody finished really early. I'm like, what? I got a lot to show you still. And that's how they all work together. And then I can use some app to connect to the API, right? I'm using Chrome. That's my app, my client application of choice to connect to my API. So the API and the container stay running while we're doing that. Now for the test, it's almost the same. Remember, my test is in a different project, and I have a different Docker file and a different DockerCompose for running the test. But I'm still composing my test app with the database and the migration, right? But it's going to be completely new. As a matter of fact, I better go ahead and, no, not there. Don't wreck my cheese and Pete's. I don't want to do it in there. Really, things won't work very well if I do that. I just want to DockerCompose down. Not test. Come on, come on. Okay, that one. That's going to take those containers back down for me, all the containers that were being managed. So if I went here, you can see there's no containers running anymore. So what the Docker test will do, and and you just start from scratch each time. Like, that's the whole point. We're going to start from scratch. We're not sharing all the actual containers. We're just sharing these DockerCompose files and Docker files inside with our source control, right? So anybody who's running it will be able to run it. So with the tests, I'm also going to spin up a database container. I'm going to migrate the database with my Flyway container and the T-SQL that it's going to be reading. The Flyway container will go away. My ASP.NET testing app will run. It will run the test. It will finish. And remember, when it's finished, it's completed, that will go away also. So that's a big difference from my API hanging around waiting for me to connect to it and interact with it. I pushed the up arrow again. Sorry. So let me just show you what that DockerCompose looks like. I'm going to close that because I'm so afraid I'm going to type over it by mistake again. So I've got a DockerCompose test and a Dockerfile test. So the Dockerfile test, that's for building an image of my test project, not the API, but the test project. And it also has an entry point. Before, I used an entry point tag that said, the entry point of this is you're going to run the .NET command, and then you're going to run it against the agilistas.dll. That's what it said in there. It doesn't work quite the same with tests, and one of the big differences because tests run and then finish, as opposed to the API, which is going to run and sit there and wait. So I did it a little differently. As a matter of fact, I spent 10 hours trying to figure out why it wasn't working until I learned this. It was actually not quite this line of code. It's something else, which I'll show you in a minute. But I just want to show you, so how does it know to run the test? It's because it's going to read this bash script, which is, I wish I could right-click and find it, but it doesn't work that way because it's just text. And it should be inside of my tests. There it is. So this is another place where I have the sleep. This is just waiting for the SQL Server to start up before it runs anything else. And then here I'm just saying .NET test, and then this is the test project to run. Okay? So, trying to think if there's anything else I want to say about the tests before. Oh, and the DockerCompose. So the DockerCompose looks pretty much like the other DockerCompose, except this service is for the unit tests instead of for the API. So I'm saying this is the name, Dockerfile test is the Docker file you should be reading to figure out how to build the image. And I'm telling it to look for the connection string in the same place. And I'm telling it that the entry point here, I think I need to start commenting out code. Not now. I'll do it another time because this works. I think I might have some redundant directions in here, and that was again because of this other problem I was trying to solve. So anyway, this is to create the container of the unit test. It can't work until the migration is completed. The migration code is exactly the same as the other set, and here's the DB service, and it's exactly the same as the other one also. So the only thing different here is that my container running the actual application I want to run is the test container, and it's just going to run, execute the tests, and then complete. But it's still dependent on the same creating the database, creating a SQL Server. It's going to create them all on the fly, and they're all going to be integrated. And this one also will understand where to find the database because it has that server name equals DB also, and I've named it DB here. So there's a big difference with DockerCompose. Come on, compose up. No? Okay, fine. Be that way. Down. I'm just making sure I'm hitting the right one. Test. Okay. So there's a big difference here. When I was running DockerCompose against the API that has to continue running, I had that -d flag in there like we saw when I was doing Docker run, which makes it kind of interactive. And that's good because I want to do something with it. By default, when you right-click and choose DockerCompose up, it puts that -d flag in there. But with the test, this took me 10 hours to figure out because nobody I was asking understood what my problem was because my context was a little different for like the Docker experts and different people. Nobody understood, and I had to just keep trying and trying and trying different things. 10 hours. So because I had that -d flag in there, one of the processes was sitting and waiting. So the database was never getting created and my tests were failing, right? Because there's that one test in there, the integration test, that is dependent on the fact that I've seeded my database, right? It hits the Agilista's API. So I just had to remember not to have that -d in there. Okay, yes, I see that that's the up there, up. DockerCompose test up. Okay, so I'm going to go ahead and run this. There's another difference you might notice. Before, all we saw when I ran the DockerCompose against the API was the listing of the instructions from the Docker file, but not anything else that was happening in all of the other images, all the other containers. But because I took that -d, that -d flag out of here, we're seeing a lot more chat coming out of there to see what's going on. And you may have noticed Flyaway was doing a bunch of stuff. So, these are just all the log files. I used to get nervous when I would see like words like something not working, whatever. And actually, it was all fine because, for example, here, successfully validated 2 migrations. I know it ran the migrations. And then down here, the unit tests are running now. Right, it's doing it in the order, and ASP.NET's the logging is very, very, very chatty. But what's most important down here is I can see that my tests passed. My 8 tests passed, and that's including the tests that really demanded that the database not only be up and running, that the schema exists properly, but also some of my test data that I anticipated was there. So that's definitely passing. So I've got this really nice setup. Everything's working for me beautifully. And then somebody comes and says, oh, we need to track some more data in our application, right? We're only tracking one focus, but everybody has lots of things that they're interested in and that they have expertise in. So we want to track a secondary focus on these agilistas. So what that means is, in my application, is I have to modify the model, right? Okay, that's no big deal. I just, add some properties to the model. I have to modify the controller because I want the controller to now not only return the primary category along with those agilista list, but I also want it to show me the secondary category. So I have to modify the controller. Again, no big deal. Now we're getting a little trickier. We're also going to have to modify the database schema because we need a new column in the database to capture that foreign key ID into the agilista table, right? And for my tests, I need to seed some extra data. I need to now seed that, right? So that maybe it seems okay until you start thinking, all right, I can do that, no big deal, because I just need, a little more SQL to modify the schema and a little more SQL to see the database. But now I need to share that SQL all the way, I'll put it in my application maybe, but now all the developers and all the testers and all the UX people, and then somehow my automated CI/CD pipeline needs to know they need to run the SQL for the schema change, right? And then in a normal world, right, that could be a pain, right? And especially with not everybody got the message, right? Some people on the team didn't do the update, and now they're having failures in their system because they didn't do the update, and so now they're starting to make changes to the code and to the model to make up for the fact that things are not working properly, and then they check them in and, right? So you've got all of that possibility. I don't know, maybe I'm being doomsday scenario, but I'm also being somebody who's been programming for 30 years, so I'm used to those kinds of problems. That's most of our time, right? The what ifs, worrying about the what ifs. But thankfully, because we've got all this stuff set up in containers, it's actually a really fluid process. So I'm going to switch over to a new branch where I've already done all this work. And I have just collapsed some of these. So I've made the change to the Agilista class, right? I added I did switch to stage 2. I gotta refresh. I hate when things like that happen. Like, where's my other SQL? Okay, refresh. I've added a third SQL file now, and this makes the change, adds the new column to my table. It also updates the existing data, that's the existing data that's seeded in the second SQL file. It seeds a little more data, so now we have secondary category information for the agilistas, and it creates an index for the foreign key constraints, right? So that's my extra SQL. I've modified the controller just a little bit. And the controller now also returns the secondary focus, right? It eager loads the secondary focus along with the agilistas. And by the way, if you're looking at what the heck is that, that's just something I put in there while I was building the test, because it's, as you're trying to figure this out, it does get confusing. You might miss a step, and your database might not be working. So I found that I needed to have that piece of information to me while I was debugging, but I would not put that into production for sure. So I've got that in the controller, and I also added an extra test. So now I have 9 tests. And the 9th test, that's not test, that's unit test, integration test. The 9th test is here. It just makes sure that the controller now includes the new property and data, and it's just looking for a secondary focus, and it's expecting this because I know exactly what data I'm seeding into the database. So I'm just going to make sure the containers aren't running, so I've got nothing up my sleeves, even though I don't have any sleeves, because it's just an expression. And so DockerCompose up. I'm just going to run the test, making sure that -d isn't in there, and making sure my race conditions don't happen. And all I'm going to look for is at the end that it says 9 tests ran and 9 tests passed. So it's rebuilding the image. It's rebuilding the API image, and also creating the other containers. It's running the migrations now on the database. It's trying to see. I see warning, error code. Like, wait, no, what? It's okay. It's okay. The unit tests are running, and it says total 9 passed. So, right, it was just really easy to make that change. I didn't have to apply the SQL. It's literally inside of my application. It's inside of my source code. All of that. I didn't have to change the Docker files. I didn't have to change the DockerCompose. I just put the new SQL in, and the existing orchestration of the Docker containers took care of the rest. Right? So now anybody, check this in, and anybody who's pulling that down from the repository now gets that change and doesn't have to do any work. You don't even have to tell them there's a change in the database schema. It just is part of your system, and it's just like any other component now in your application. I'm going to show you, so the lines go down, one more thing very quickly, which is just about the pipeline. So what I've done is I've created an Azure pipeline that is triggered by a change in a particular branch called test master in my GitHub, right? It's tied into that. And what it does is it runs the test app, right? Which means in this case, there's other ways to do it so it's more efficient. So what it's doing is spinning up a new Linux container. It's reading the DockerCompose file. It's a brand new container, right? So it runs Docker engine on the container. It's going to look at the DockerCompose and say, okay, well, I have to pull down SQL Server from scratch, the SQL Server image from scratch. I have to pull down the ASP.NET Core images from scratch. So it actually takes 4 minutes to run this. Don't worry, I'm not going to. There is a way to kind of pre-build some of it so that it doesn't have to pull all those images down. I just haven't gotten there yet. Maybe I'll go talk to Donovan and have him teach me how to do it. Who did the keynote this morning. But what I want to show you is it actually keeps logs of, when this pipeline, there was something else important to show you about the pipeline. The pipelines for both the API application and for the test are also in my source code. So they go into GitHub, and it goes over to Azure Pipelines, right? All the integration is there. So it's just all totally connected, which is really, really cool. And one thing I can see in the pipeline, let me see if I can make this font bigger, right? These different logs, all the different things that happen. But the one I'm interested in is what happened when I ran the tests. And just scroll down to the bottom, because we know what we want to see, which is down here, total tests. I don't know if I can't highlight it. Total tests 9 and total test pass 9, right? So even into my CI/CD pipeline, it's just reading all of my source code, getting everything it needs, spinning up the containers. Oh, and when it's done, not only it just throws everything away, not just the containers. This is going to throw away the Linux virtual machine that it created to host all of this, right? But just totally automated. So all the way from across my team of developers and testers and the UX people, but also into the CI/CD pipeline. Then the last thing I just want to make sure you're aware of, like I had that pipeline tied to my test master branch in GitHub, right? I could have different pipelines. I could have a pipeline that builds and runs my API, so I can try to do some, just like actually use it and see how it works for pre-production. I can have a pipeline that builds and runs the test. I can have another pipeline when things are ready that literally publishes it, right? That would be a different pipeline. And the DockerCompose might be a little different, right? I'm not, for example, I'm not going to push my test data in. I'm probably not going to create a new database, right? Maybe you're going to have SQL Server and containers in Kubernetes. People are scared of that right now. Just remember 8 years ago, we were just as afraid to have them in virtual machines. So we'll get there. But you could also just say, OK, now my connection string points to an Azure SQL database, right? Like, it's just all configuration. So that was everything I wanted to show you. Sorry for the 5 extra minutes. Yeah, I hope the idea is that the line's shorter, not that all the food's gone in those 5 minutes. But more importantly, I hope that this opened up your eyes to some new possibilities that you'll be able to take advantage of. I hope if you've never seen Docker before, perhaps you had a little bit of your Docker aha moment. That would really, really make me happy. DockerCompose, the pipelines, all of these things. But just to be able to have a database as, like as a no big deal in your software system, especially during development and tests. It's like, it's not this big, huge thing that we have to go install and manage separately and have a DBA to take care of. The real production database, absolutely, right? But for the databases that we use on our development machines, it doesn't have to be a big deal. So that's what I wanted to share with you. I hope it was interesting and helpful, and that you'll be able to do it. And I'm happy to take questions. I can stand here and answer questions if you want to wait for the lines to get shorter even. But otherwise, thank you very much. Yeah, enjoy the rest of your day. Slides have resources. They'll be available on my GitHub repo. And there's my contact information. So thanks again.